Hi everyone, welcome to our final video in this series. We introduced in the previous video some trigonometric graphs for sine and cos. And what we're going to be doing in this video is using those graphs and the information on it to estimate certain trig ratios, first for this first question, and then in the next question comparing some trig ratios visually and graphically. So let's just jump straight into it. We've already introduced these graphs, so let's just get started here. Now, in this question, it says use this graph of cos theta to estimate, so in part A, the value of cos theta for theta equals to 200. So we're putting in some input here, and we're going to get out some kind of ratio of cos theta. So these trig graphs are just like the functions we looked at in previous topics. You put one thing in, you get one thing out. So what we want to do first is we want to roughly locate about 200 degrees. Now, once again, this is just a rough estimation. So I'm going to say that, okay, 200, I've got 180 here. 200 is going to be about here. And I'm going to draw a dotted line down to some particular point here. And from here, I'm going to draw it across. I've got my input, my x value of 210 degrees. Or my theta value here, because my theta is on my x-axis now. And I'm going to get some output y, or some output cos theta, some kind of ratio. So now that I've got that there, I can see it doesn't quite go down to -1 here. So I'm just going to draw a dotted line across just to see where that leads me. And I'm going to see that gets me very close to that. So I'm going to say that this is going to be approximately -0.9. Because remember here, we're just approximating these. So A here, I have the cos of 200. My input here is 200 degrees. That gives me around -0.9. And if you pop these into your calculators, you probably won't get exactly that, but you'll get something quite close. Remember, here we are just estimating some trig ratios. Okay, now in the next bit, we're asked to find two values of theta. So we're finding the input now, for which cos theta equals 0.7. So what we want to do first is we want to roughly locate 0.7. Now I'm going to say that's about, let's use a darker color, about here maybe. So around 0.7 here. And what I'm going to do, I'm just going to draw a horizontal line through all the way across, and I will see, you guys will see hopefully, I actually have 2 points on my graph that I cross. One is going to be here, and one is going to be over here. So now, I just want to draw a line down. So I'm going to draw a line down here, and a line down here. Okay, and I'm going to roughly sort of measure this thing here. Now, I've got the first one. This looks like it falls about halfway between 0 and 90 degrees. Well, if this is the halfway mark about here, it looks like it's just to the right of that. So halfway between 0 and 90 is 45 degrees. So just one across from that is going to be about 46 degrees. So if we have the cos of theta equals to 0.7, my theta, the first value of it is going to be around 46 degrees. And my next one, I'm looking for somewhere in between 270 and 360. So this is about, over here is about halfway in between. So we have another 45 degrees, because these are all separated by 90 degrees. So halfway between those two is going to be 45 degrees. So this one here, just slightly to the left of 315 degrees, let's say that's approximately 313 degrees. So all we are doing is we're just navigating an XY plane like we did a while back from when you first got introduced to this back in year 7. But now we're looking at different types of inputs and outputs. Since these are trig graphs, my input is theta, my output is going to be cos theta or sine theta. And we're just trying to navigate this in the same way as we've done before. Now in the next question, this is saying use the graph of y equals sine theta to state whether or not the following are true or false. Okay, so in order to do this, we want to first draw up my graph, our graph I should say. Okay, and we're going to draw this along here. And I'm going to give just a rough sort of sketch of what this kind of looks like, but we remember our sine graphs look sort of like this. And we remember that these are my main sort of points on my graph. So halfway through the cycle is 180 degrees, the end of my cycle is 360 degrees. Now halfway between here, I'm going to get 90 degrees. And here is going to be 270 degrees. Okay, so once again, I am trying to locate the outputs here for the inputs of 70 and 130 degrees. So first of all, I will see that, okay, 70 is going to be, if I'm looking at my theta axis here, 70 is going to be a little to the left of 90 degrees here. Let's say about here. Now, if I draw this up, this is going to give me a point here, which gives me some kind of ratio over here. So I have 70 there. Okay, now I'm looking for sine of 130 degrees. So I'm going to go a little bit further here, because there's 20 degrees separating 70 and 90. So there's going to be 30 degrees separating 90. Ooh, jokes. 40 degrees separating 90 and 130. So I have to draw this a slightly bigger distance from this one over here. So if I draw that up, I'm trying to see which one gives me a bigger trig ratio. And my trig ratios are given on my y-axis. And I can pretty clearly see here that my 70 degree input gives me a larger output than 130 degrees. Because my 70 winds up here, and my 130 winds up a little bit below it. So I'm going to say this thing is in fact false. Because in this case, my sine of 70 was actually greater than sine of 130. So let's look at part B here. I have sine of 195 degrees. Okay, so that's about here. Really close to 180. Let's draw a line there, and I'm going to stretch this along to here. Okay, and I have sine of 335 degrees. So quite close to 360. So 335, let's say that sits around here. So I draw it down, and then I go across to see what ratio this gives me. And from here, I can pretty clearly see if this is 195 degrees, and this is 335 degrees, that my sine of 195, that is higher up on the y-axis, on the horizontal axis, than this one. So this guy is in fact true. And all I'm doing here, I'm just putting in an x value or a theta value, a value on my horizontal axis, drawing a line up to my graph, and then mapping out where that reaches on my y-axis. And this is how we're going to start to use these graphs to determine which ratios are bigger than others. And we can see the ratios are constantly changing as we cycle through this graph. The ratios start at 0, they get bigger up to 1, they go down to 0, they become negative. They're constantly changing, and they change based on the angle values that I put into those trig graphs and into those trig ratios of sine and cos. But that brings us to the end of trigonometry here. We will look at these graphs a lot more in later years, but that is out of the scope of the content we're doing now. So this lays down the foundation for a lot of the things we're going to be doing later. But thank you so much for joining me, and I'll see you in the next series.